So we had basically on the 23rd of October 2007, on the 7th of February 2008, and on the 9th of March 2008, respectively, the launch of the Node 2, the Columbus module, and the ATV Jules Verne. This is represent something like 50 tons of hardware put on orbit. So this is really serious business, especially if you know that the cost of a program can be very much equated to the cost per kilo. We had, in the same time of launching our element, we had the opportunity to have 3 European astronauts flying to the ISS, namely Mr. Paolo Nespoli, flying on the Node 2 assembly flight, and Hans Schlegel and Leopold Ehlert flying on Flight 1E on the Columbus assembly flight. This is a view graph that in our directorate we are very proud of, because this represents all what we have done together with our industry since something like 15 years. This view graph needs to be read clockwise, and it represents all the contribution of ESA to the space station. So we start with the data management, the computer of the Zvezda module, the service module, the Russian service module. Then we have the microgravity glove box being launched also in the year 2000, in 2002 actually. Then the EMCS, which is a payload, a scientific facility. Then the minus 80 degree freezer, which was launched in the year 2006. And more recently, as you can see, the Node 2, as I have mentioned, the Columbus module with all its payload facilities, then ATV. Now what remains to be launched is the ERA, which has a launch under review, the Cupola, and the Node, which will be launched in October 2009. So you can see that the circle is really closing. Few words now about the various recent launches that did occur. The first one is the Node 2. The Node 2 is an ESA build element built by Thales Alenia Space in Turin. It's not an ESA-owned element. It's ESA that has built this element to compensate NASA for the expenses they had to launch the Columbus flight, so the Columbus module. So instead of paying NASA in dollars, we have established this barter arrangement, which is widely used throughout the partner of the ISS, in order to compensate the effort that the other partner has done to put us on orbit. What is the function of the node is, as you can see on that picture, is an interconnecting element that allows to link the US lab to the Columbus module, the Kibo module, and also to the HTV and to the Japanese logistic module. Few words about the development history. I have already mentioned that the prime contractor of the node was Thales Alenia Space, and they have developed the Node 2 under the leadership of the Italian Space Agency that had the delegated responsibility to manage that given program. Few words about the 10A assembly flight, which is the launch of the node. So it was launched on the 23rd of October. After a flawless launch, the node was positioned on this intermediate position that I'm going to show here. So the shuttle was here. Then, when the shuttle left the station, the node was repositioned in the front of the station where it is now. Since then the node is working flawlessly, delivering all the resources the other element attached to it requires. Now we get to the plat de résistance, which is our Columbus assembly flight. This was the 7th of February. For many of us, it meant a lot. The Columbus development has been a bumpy road in terms of programmatic difficulties. We had suffered a number of slowing down in the program due to reasons that were not generated by the program itself. The shuttle accident is one of them. And it has been extremely challenging for us to keep the motivation of all the teams working on this program and to keep also the cost within the envelope we were assigned to keep. Few words about the Columbus performance. It's a 12-ton vehicle. It has about 13 kilowatts to the payload. It has 120 volt power. Also, it has communication capability up to 32 megabit per second. It provides active thermal control to its payload and to the subsystem, and it provides support for 3 crew members, and it has a design life of 15 years. What are its features as opposed to its performance? Columbus provides a short-sleeve environment for up to 3 crew members. Actually, this is not true, because during the Flight 1 mission there were up to 10 there, and apparently they did survive. Nevertheless, we did size it for 3. It can accommodate up to 10 payload scientific facilities and 4 external payload facilities on its external platform. It can operate 10 years on orbit. It has the capability to be repaired while working. Usually when you have a ship and the ship is to be repaired, you put it in a hangar or a plane and you repair it. This is a machine that still can deliver its normal services and being repaired. And this is introducing few little design complications that we have enjoyed. This is an intelligent system that can make his own health check and decide if he's healthy or not and reconfigure itself. Usually a satellite sends you some telemetry, and you see telemetry healthy or not healthy, and then you send a command from ground to reconfigure it. This is a system that is able to reconfigure itself. So he is able to detect his health and to cure himself, which is also a high degree of sophistication. And by its design, we have been able to maintain, we have generated, let's say, a very compact design that was able to remain within the 12-ton allocation, and therefore we had in one single launch all our infrastructure on orbit on the first go.